Hi all, so you'll notice that these videos look a little bit different than they have before, and one of the main reasons for that is that we're actually using the PDFs for the guided notes that either you have in a packet, or for this one, this is something I've added in because I think that having this additional 2 days of practice where we're working on evaluating with rational numbers is going to be really helpful. So if you want to print this out, otherwise you can take these notes in your homework notebook, following along just like you would if we were in class. The homework is split up into 2 days. We have day 1 from 3.5 with the presentation problem number 10, and day 2 from 3.3 and 3.4, and the presentation is from 3.4 number 22. So let's get started. Now, the first day, we're going to be talking about adding and subtracting rational numbers. So let's quick define rational numbers. A rational number is any number that can be written as a fraction. Now, obviously, things like fractions, which we see here, can be written as a fraction, as can mixed numbers, and some decimals. So repeating decimals are fine. For example, 0.3 repeating is equal to 1/3 as a fraction, but a non-repeating infinite decimal like pi is not. Other ones that are fine are what we call terminating decimals, which means that they end, and that can also be written as a fraction, where you just take the decimal and put it over whatever spot it goes to and simplify. So, what we're going to do is a little review. If you don't feel that you need to do all of these problems in the notes, you feel like, I remember how to add and subtract, I remember how to multiply and divide, that's great. Go for it. If you want a little review, this is what this is for. So, there's a lot of different approaches to most math problems, but you're going to have some things in common, such as when you add and subtract fractions, you need to have a common denominator. So for example, the denominator is the number at the bottom of the fraction, and common means it has to be the same. So if I was going to do this subtraction problem, there are two options. You can either leave the mixed number as is or turn it into a fraction. I'm going to turn it into a fraction. To do that, we multiply the 1 by 6 because this is the same as 1 plus 1/6. So this is 6/6 then, and we add the 1 over. So we end up with 3/8 minus 7/6. Now we want a common denominator here. We ask ourselves, what is a number that they both can be multiplied to equal? Now, a trick that you can always multiply them together, but usually there's a smaller one. So in this case, it's 24. So I'll multiply the 8 by 3 to equal 24, and the 6 by 4. And because it's a fraction, we need to multiply both sides of the fraction by the same number. Multiply this by 4. And now we have the common denominator, 9/24 minus 28/24. When we combine them, we just combine the numerators, and the denominator again stays the same because it's a common denominator. It goes all the way through. And now we just need to simplify. 9 minus 28 is negative 19/24. We want to ask ourselves, it can be simplified. In this case, 19 is prime, so it's not going to divide by anything. Now, you'll also have some in the homework where you're substituting, meaning you take a number and you plug it in here. So that's the first thing that I'm always going to start with. So 2.5 minus negative 4/5. And then I'm going to simplify the negatives here. There's 2 without a number in between, which means it turns into 2.5 plus 4/5. So again, we're adding rational numbers. So you can either make them a common denominator by turning 2.5 into a fraction, or you can add them as decimals by turning 4/5 into a decimal. It's up to you. I'm going to decide to turn this into a fraction, and so that would be 25/10, because it goes to the 10th place, plus 4 over 5. Common denominator here is 10. So multiply the 5 by 2. And we end up with 25 over 10 plus 8 over 10 adds to 25 plus 8, which is 33 over 10. I am just fine with you leaving things as what would be called improper fractions. I just call them fractions. They're great. You will use them all the time in upper level math. If you want to turn it into a mixed number or decimal, go for it. Do not feel like you have to. You now have enough topics to go through day 1. If you want to pause the video here and come back tomorrow for the day 2 problems, you can. Otherwise, you can keep going, and then you can have a complete workday tomorrow and do some of your homework today. So day 2 is about multiplying and dividing fractions. And so we have here, we are going to start with our multiplication problems. Now, when we multiply fractions, or really any number, the first thing I want to do is start by simplifying the negatives. So in this case, we see we are multiplying two negatives together, so I know that my final answer is going to be positive. And then I'm just going to take the numbers 2/7 times 21 over 50. Now this is a special thing with multiplication. This only works with multiplication, but that means that you can simplify now. Again, this only works with multiplication. It does not work with addition, subtraction, division, exponents, anything else. But if it's multiplication, you can say, oh, well, 7 and 21 would be a simplifiable fraction. 7 divides 21, and we are left with 3 and 1. We also can simplify with 2 and 50. They're both divisible by 2. And now that we have a simplified fraction, we have 1 times 3 in the numerator, because with multiplication you just multiply straight across, which is why you can simplify now, unlike everything else where you have extra steps, you can't just add straight across. And here, in the denominator, 1 times 25, leaving us with our final answer of positive 3 over 25. Now for number 4, what we see here is we have a fraction times a whole number. So I'm going to start by putting that negative out in front, because I know my answer is going to be negative, because there's a positive times a negative. And then I'm going to rewrite 4 as 4 over 1. So if you ever have a whole number and you want to multiply it straight across with a fraction, you have to put it over 1. And then times 7 over 8. Here we're multiplying, so we can simplify the 4 and the 8 as 1 and 2. Multiply straight across, remember that negative, so this becomes negative 7 over 2. Again, you are absolutely fine leaving it like this, or it could be negative 3.5 or negative 3.5. All of these are just fine ways to write the answer for this problem. Finally, let's look at division. Now, if you hopefully would remember from previous classes, division means that you are multiplying by the reciprocal. Now, the reciprocal is where you flip the fraction. So whatever's in the numerator here and the denominator is going to change. And so the reciprocal of this fraction would be just the opposite. And we're going to turn the division sign into multiplication. Now, here, this only works with fractions because you need a reciprocal, you need a fraction. So the first thing you want to do here is you need to change these mixed numbers. And so just like we did earlier, we're going to take 5 times 3 plus 2. So this becomes 17 over 5 divided by, and here it'd be 2 times 2 plus 1, 5 over 2. Now here, if this was multiplication, we want to simplify. Don't. You have a division sign, and you'll see why that wouldn't be correct in a second, because now what we want to do is we want to multiply by the reciprocal. So meaning we're going to take our division sign, multiply, but then we have to switch the second one. If you're not sure which ones to switch, it goes multiply by the reciprocal. So multiplication comes first, and then the reciprocal. So you'll notice the first number is the same times the reciprocal here. So this problem turns into 17 over 5 times 2 over 5. And now it's multiplication. We can just go straight across. None of these terms simplify, so we just say 34 over 25. Again, just fine leaving it like this. It's lovely. If you want to turn it into a mixed number or decimal, feel free. Now another way to write division is using a fraction sign, which hopefully makes sense. This is the line, and then there's something on top and something on bottom. It's division. Now, the first thing we're going to do is substitute in our x value. So we have 0.5 divided by 2.15. Now there's a lot of ways to do this. You could turn it into a long division problem. That's going to get a little bit tricky. The thing that I always recommend is if you move the decimal 2 places to make this a whole number, and you do the same thing in the other side, we'll fill in this missing spot with a 0, just like we would with scientific notation. Now we have a very nice fraction that's going to be reasonably easy to simplify. We have 50 over 215. Both of those are divisible by 5. And we get our final answer of 10 over 43. So these are going to be your next 2 days working on this. Let me know if you have any questions, and if you are stuck or want to talk about some things, please feel free to grab an appointment. I know that it's not an assignment this week because you don't have a test, but they're still strongly encouraged.